factor out the dy dx. And once I've factored it out, I divide by that whole set of parentheses. So then dy dx is equal to 3x squared divided by 4 minus 2x sine of 4y, all divided by 4x squared cosine of 4y minus 4x is y cubed. And that is implicit. Alright, so you want an optimization problem. Alright.
And I'll for after you do the optimization problem, can you do one that was like whoops. Can you do one that was like
Yeah, I know what you're doing. I know.
Okay.
So you do optimization problem.
Are you doing one off the,
Do you want me to do one on there?
Yeah.
Yes, which one do you want me to do up here?
which one is pink number?
Number
Is that
11.
option?
Number 11 is there, number 12 you mean? Find the height and radius of the cup that will use the smallest amount of paper. All right, so I've got a radius and I've got a height. Okay. So volume is something I know. It's going to hold 27 pi cubic centimeters. What's the volume of a cylinder?
pi r squared h?
Pi r squared h, just like all the way up. Okay, so I know this is actually equal to 27 pi. In other words, you cancel the pi's and I get that r squared h should equal 27. Okay, so that's one equation I have. What is it that I'm trying to show? Well, I want to know what is the radius and the height that will use the smallest amount of paper. Well, the smallest amount of paper, that's really asking me for the surface area, right? So I want to know what is the surface area? Well, the surface area is going to be the amount of paper all the way around plus the amount of paper on the bottom. Okay? There's no paper on top because it's a cup. You wouldn't be able to drink out of it if there's paper on top also. So the surface area, I'll use A. Well, for the bottom, what's the area on the bottom? Pi r squared. And how much area is there going around the edges? 2 pi r times h. Does that make sense? Why it's 2 pi r times h? If I cut the paper and unfolded it, it would look like a rectangle. The total length would be the length all the way around. The circumference, 2 pi r. The height would just be h. Okay. All right, so this is what I want to find the minimum of. I want the minimum amount of area. Okay. Well, I don't want two variables, I just want one variable. So I can use this equation and solve it for one of the variables. It'd be easiest to solve for h, because the h isn't squared. Okay. So this is really like saying h equals 27 over r squared. And then I'm going to use that and plug it in up here. So I now know that the area equals pi r squared plus 2 pi r times 27 over r squared. Well, one of these cancels with one of those. Okay. So I really end up with pi r squared plus 54 pi over r. That's the area. How do you find a minimum? Take the derivative, find your critical values, and then one of those critical values will most likely be the minimum. So what is the derivative?
2 pi r.
2 pi r minus 54 pi
R to the negative 2.
r to the negative 2, which is like over r squared. Okay. All right, so now this is what I have. I want to set this equal to 0 or undefined. So let's get one fraction out of it. This will be 2 pi r cubed over r squared. Right, multiplying top and bottom by r squared over r squared. Minus 54 pi all over r squared. All right, so notice I can factor in the numerator. I can factor out of 2 pi, and I'm left with r cubed minus 27 all over r squared. So what are the critical values that I have? So not plus or minus 3. Negative 3 cubed is negative 27. That would work. Just positive 3 and 0. A radius of 0, is that going to make sense in this problem? No, then I wouldn't have a cup. So automatically, you can ignore that one because it doesn't make any sense. So the critical value of 3 is likely going to be when that minimum occurs. Okay? Now we can check to see when that minimum occurs by finding a second derivative and plugging it in, or we can make a table and see, well, was I increasing and then decreasing, or decreasing and increasing, whatever. Okay? If you do that, yes, this will turn out to be a minimum. Okay? So how do you want to check? It is a minimum. So that is
You take the second derivative and plug it in, you're looking for concave
up,
up.
right? If it's concave up, you have a minimum. Exactly. Okay. All right, so if I see that I have a minimum here, then to answer the question, I want to know both the radius and the height. What is it that I found? This critical value of 3 is the radius. Okay, so I know my radius is 3. So my height, well, here's what I know. I know the height is 27 over r squared. The height should be 27 over 3 squared, which is 27 over 9, which also happens to be 3. So 3 and 3 would give me that minimum area. So what's the process? Every time you want to do these types of optimization problems, the process is to come up with 2 equations. One of them, you'll solve for one of the variables and plug it into the other equation. Okay? You simplify, take the derivative, find what it's either 0 or undefined to get your critical values, and then figure out which critical value was the max or min that you were looking for. That's, in general, the process of how you're going to do all of these.
I think it's like we were gonna have those, delta sigma problems that we had like in the very beginning.
Oh, the epsilon delta problems?
Epsilon delta.
Probably, I don't remember seeing that on there, but I don't want to tell you for sure yes or no, because I haven't seen the final exam to know.
I don't know, like where it was like the definition of the limit, basically, where it was
Yeah,
the
that's,
absolute value of the function is less than epsilon.
yeah, so given any epsilon greater than 0, there's a delta greater than 0 such that if absolute value x minus a less than delta
Those are not
implies
that bad.
absolute value f of x minus l less than epsilon.
Can we do the, want to talk about because I'm running out of battery now.
Okay.
Hope I get that on video for
All right, so
easier
what do you
review.
want to do? You want me to just make one up? Just make one up for you?
Sure, something of similar complexity that you would expect to be on the exam should be in.
Okay, so let's take part, I don't know how nice this is going to come out, I'm just making it up. All right, part of the parabola in the first quadrant, given by y equals about, let's make it nice, 4 minus x squared. Cross sections kind of look like this in that first quadrant. Here's 4, here's 2. I'm perpendicular to the x-axis, so it will look kind of like this, and when it stands up, having hand-eye coordination issues today. All right, there's my parabola. So I'm going to stand up, and I'll have a square standing out. That square will have a little bit of a width. So the volume of my square, well, how long is this base? Y, the Y value of the curve. So the base is Y, because it's a square, the height is Y. So the volume is Y with dx. Let's shoot, I don't want Y squared, I need it now in terms of x's. But what do I know? I know Y equals 4 minus x squared. So I can just replace it. So to find the volume of the whole shape, I'm going to integrate over the whole area because it's in terms of x. It goes from 0 to 2 of 4 minus x squared dx. And then how would you integrate that? Well,
Multiply.
FOIL, multiply it all out, and then integrate it right now.
Okay.
Okay? Does that
Yep.
help?
Yep. That's good. Also, last, very quickly, can you just at least in general explain how to do like one of the shell problems from 6.3?
Let me do that in a little. We just did the shell problem. So in general, the idea of the shell problem is 2 pi r h the r is integrated. You just have to draw your shell, figure out your radius, figure out your height. Your dr is the same, whatever variables you use for your r.
I meant, yeah, but it was different from the one it was different from the way we did it in 6.2 with the cylinder and stuff though.
Pretty much the same, except it's just that we use this formula rather than pi r